Good afternoon, everyone. I think like we're ready to get started. Before I start off, I'd just like to say for those of you that may have attended last year's WinHEC, that anything they may have seen materials related to something called Cornerstone, or Secure Startup, or Full Volume Encryption. All of those have now come to be known as BitLocker Drive Encryption. So if you have any questions from last year about where did that technology go, or what's this BitLocker thing, you know that you can ask them all of the same people. Now, whenever I go to a conference, something like this, it's always interesting to talk with the people. In a room of this size, it's clear that with all the technical expertise in here, there are years of technical security experience. Now, as you all well know, there is always more than one threat to a system. You can set up an amazing firewall. You can lock down your network shares. You can take a DNA sample from anyone entering your building. And have you ever seen the movie Gattaca? Believe me, things like this is just the first step in some organizations. And yes, it does scare me too. But the point is that if your system falls into the hands of an attacker, history tells us that pretty much all bets are off. The odds are surprisingly good that if that system is lost, it won't even have a password on it. And if that's not the case, the odds are still very good that all an attacker would have to do is pop in a certain CD with special tools and be able to inspect and read data from that volume. But does that really happen? Do systems really fall into the hands of an attacker? Let's take a look. Government laptops not secure. Thief swipes more than a laptop. Lost laptop. Stolen laptop. I think we're all getting into the pattern here, so I'm just going to skip down to the point. The point is that any of you with 10 minutes can search for laptop and stolen and yield results that will show hundreds of things exactly like this. Now, I'm of the opinion that when something like this happens, it's really no one's fault but the thief. By and large, these organizations have security policies. They follow them. They're doing the same sort of things as everyone else. The problem is that when you are an organization of this size, when you have 100,000 machines, some of them are going to get stolen. It's an unavoidable fact of doing business. You can't know where 100,000 or even more machines are every second of every day. This just highlights and underscores the need that the importance of physical data security has always been at least on par with that of electronic data security. It just hasn't been manageable on a large scale. So before we get into the real details of the presentation, we're about to dive pretty deep and pretty quickly into it. And I just wanted to help set the tone for this presentation. Now, looking around the room, I see many of you that I do know, that I recognize, that I already work with. So thank you for coming. I know there are many more of you that I've spoken with or interacted with on some level, but haven't had the opportunity to meet personally. Now, for those of you that do know me, you know that a large part of my day-to-day role within Microsoft has to do with partnering with each of you to help make platforms that are more reliable and more secure. My goal in doing all of that is to help us all build products for our joint customers that make them happier, that make them more productive, with ultimately to make them more secure. Now, to that end, I've put together this slide deck to be as useful and as practical as possible for you long after this presentation. The reason I got up here to give this presentation today, and the reason I agreed to do this is not just so I can show information about BitLocker. It's because I want to help each of you build platforms that are more secure. I want to make sure that everyone in this room has absolutely everything they need to know to get a Windows logo. And ultimately, so it's after seeing all the great work that we've seen pulled into Windows Vista and into the industry over the last several years, help us all build products and services that can help secure civilization and help make our world of technical security a better place. Many of you may already know what BitLocker is, but I want to just give you a brief overview of that. BitLocker is designed to help protect data even while it's in the hands of an attacker. Now, the most obvious scenario for this is obviously that of just a lost laptop. These kind of things happen all the time. But servers and workstations also sort of have a way of walking off on their own as well. As a general rule, anything that's ever been used for business, the odds are very good that there's at least something of value on it. Now, BitLocker is designed to help protect this data. It's designed to be transparent It's designed to provide the ability for a user, if you so choose, to not even need to know that it's there, to know that a TPM is there. Now, Microsoft has poured tons and an incredible amount of effort over the last several years into hardening the operating system. Developments in anti-malware protection, user access control, the security development lifecycle that all of Windows Vista is based on, firewall protection, network protection, anti-spyware, virus protection. All of these things have dramatically raised the bar for an attacker. Now, unfortunately, this is all based in software, and many of the key protections that software can provide for your data are greatly mitigated if that machine is never turned on. In the past, if an attacker was smart enough and skilled enough to rip apart your machine, pull out the hard drives, and just start scanning optically for data, much of the value of the protections that the OS can provide is mitigated or is lost. BitLocker, as I said, is pretended to prevent this, to be as transparent and as usable as possible, and to be scalable on a massive scale, on an enterprise scale, on a scale that the good guys need to be able to protect data from those few that would want to obtain it and exploit it for their own purposes. Now, by using a trusted platform module or a TPM, we'll get to more on that later, we can help lend a stronger assurance that data stays where it should be. And with the right combination of, say, security policy and technical advancement, if not protect that data outright, at the very least, try to protect that data well beyond its useful lifetime. Now, this slide is a lot to absorb. I understand that, but we'll take it one point at a time, and we'll see if we can make it all make sense. First, BitLocker can be set up in different ways. It provides the flexibility to be able to be customized depending on the needs of a given organization, depending on the threats that they are concerned with, depending on the level of user impact that they are willing to accept. Second, BitLocker is designed to protect data on a hard drive, either while that hard drive is sitting there safely humming away in an office, or, if worse comes to worse, if that hard drive should ever find itself disassembled and in pieces in a hacker's workshop, at the very least, help provide a very non-trivial level of protection, an additional layer to help secure your data. Microsoft has also provided a single, universal TPM version 1.2 driver. And what this means for you is that any TPM, or BitLocker should be able to work with any TPM, provided that it is fully TCG compliant and TPM version 1.2. If you have any questions about a TPM supplier that you're evaluating, or whether or not that will work with Microsoft and with Vista and with BitLocker, give us a question. Ask us. Ask your TPM suppliers, are you TCG compliant? Is it a TPM 1.2? Just make sure you have everything in order, everything you need to be able to support TPM use within Vista. The TBS, that's the next point, and this enables us to be working with a trusted software stack, enables third-party utilities and third-party applications to have full use of the TPM within the operating system. This allows for additional development on different fronts and allows innovation to flourish within the Vista operating system. Next up is the Active Directory backup. Now, for those of you that plan to attend the next hour's session, I highly recommend it. I have seen it, I've pronounced it awesome, and I am sure that you won't regret it. For now, we're just going to say that Active Directory is what enables us to encrypt and protect literally hundreds of thousands of machines without having to go sit down in front of each one of them and write something down on a little note card, or whatever the case may be for other tools you may have deployed. And last, I sort of say this in jest, but I think there's some truth to it. Since we technology people all kind of miss the old days, and we like anything that looks like DOS, we've provided a number of scriptable command tools that enable you to take care of BitLocker settings, to manage TPM hardware settings, and to remotely administer and configure BitLocker-enabled machines. So what does this all look like conceptually? We'll just take a quick look at the architecture and have an idea of what the foundation of BitLocker is based on. Now we'll start at the bottom with a TPM. Now, for now, we'll just say, we're about to get this in a lot more detail. There's other slides that will talk about the TPM. For now, we'll just say that the TPM is a security chip. I see. And any of you that may have been sitting next to someone who is now groaning or wincing will realize that they're probably a TPM manufacturer. Now, I know it's a lot more than just a security chip. It's really a miracle of modern engineering. But that said, it is incredibly useful. TPMs provide some key abilities and some very interesting technology that we look forward to developing on. I know I have an office full of them. And luckily for industry and for customers, even the prototype units I've seen thus far are all looking very good. So you'll notice that some of these boxes are in orange. Everything necessary to have an application communicate to a TPM, remotely administer a TPM, and interact with third-party services, applications, or utilities is all there in every version. Now you may also notice that part of this is in blue. Now, although BitLocker can be set up to be transparent and to be very little impact to the user, secure, lasting deployments often require the kind of technical expertise and infrastructure that just isn't available in the home environment, whereas enterprise and ultimate customers can be understood to be able to manage things like recovery keys, encryption keys, and remote deployment of BitLocker machines, and to secure that information over the long term. So before we get into this, I know that many of you are already well aware of what TPMs are. Many of you actually build these things, and you know way more about them than I ever will. For those of you, just please bear with me. We're going to go into the little details of it. For those of you that don't know what a TPM is or aren't as familiar with it, I still think that's definitely understandable. This technology is relatively new, and it's not yet entirely widespread. As you can see, a TPM is usually a small chip soldered directly onto the motherboard. It contains its own trusted storage and logic processing circuits, and it's designed to have the ability to help protect secrets. By being able to manage endorsement keys or encryption keys, we have the ability to make a computer create data and read data in a more secure environment. Now, by gathering certain bits of information from all the different pieces of a machine, if we can put that together, we can lend a greater assurance that that machine as a whole can be trusted. TPMs also provide something called a root of trust. We're going to get to that more at the next slide, but it's important to recognize that the hardware is very important. Last, most TPMs are also highly tamper resistant. Now, all of the mechanisms and ways that this is done are proprietary. We can't go into the details on that, but I can tell you that many of them that I've seen are tricky, devious, and some of them are downright unfair if you are the type of person interested in breaking into one of these. Now that said, I think we have to be careful to point out that no security is flawless. Something that we built 100 years ago, the odds are very good that we'd be able to break it today. The point is that more protection is always better than less protection. And if you want your platform to have more protection, something it should have is what's called a root of trust. Now, what a root of trust means is that deep down at the lowest levels, when someone flips a switch and a computer first begins to turn on, that computer sort of conceptually crawls out of the electronic ocean and it starts evolving into a fully developed operating system. Providing a root of trust means that we do absolutely everything we can to make sure that those first steps are trusted. Because if those first steps are trusted, we have the ability to extend that and to realize that if we can check every step along that road, along that path as we develop up into the operating system, we can lend a greater assurance that the operating system itself can be trusted as well. A root of trust based in hardware provides a number of key advantages over a root of trust based in software. Now, software utilizes a shared memory space. It has to rely on something else to do memory management. Now, as we just mentioned, a TPM contains its own internal firmware and logic processing circuits, which it can use to process instructions. This helps shield it from a number of external software vulnerabilities. Additionally, TPMs, the tools and skills used to attack TPMs are often either not as available or much more expensive than those used to attack software. You can't just go down to the local electronics store and pick up the soldering irons, your acid baths, your heat lamps, your voltage regulators, bus jacking tools, focused ion beam systems, or the electron scanning microscopes that might be able to help you break a TPM. Now, of course, that's not necessarily something that not every TPM is going to need all that extra effort. The point is that with all those tools and the additional level of complexity involved in doing that, even if you do succeed in somehow breaking into a TPM, obtaining the TPM secrets, because it is a unique physical object, the odds are very good that you've broken one platform. All that time and effort, and you've broken one platform. This makes hardware root of trust, attacks against that, much more difficult to distribute. You can't just post a focused ion beam system on the internet or email it to your friends. Obviously, these types of attacks require something that usually are done on a one-off basis, providing much greater security to the community as a whole. Now, maybe this sounds too good to be true, and I think anyone in the security community, myself included, will probably say that it is. There are additional threats, there's things that we can't anticipate. But let me ask you this. Do you buy a big iron safe because you think it's impossible for anyone to ever get what's inside? Or do you buy it because it provides the level of assurance, the level of protection necessary so that the time and the effort and the resources and the money and the skills necessary to get into that won't be worth it for whatever's left inside? So what exactly are we doing? How are we accomplishing this? Now, BitLocker is a piece of software, right? And at the first times when the computer is loading, BitLocker isn't even loaded. So how do we help protect your operating system? This diagram is a bit simplified, but it gives us the right idea. Now, as we just mentioned, a TPM contains its own trusted storage. By taking measurements, or what we call hashes, it's essentially a one-way mathematical computation of components, say the BIOS, for example. We can assure that this exact BIOS produces a unique measurement, and that this exact BIOS will produce the same exact unique measurement every time that we measure it. We can take that value, place it into some of the storage on the TPM. Now, if we do the same thing all the way down the chain, we start with the master boot record, the boot sector, the boot block, many other components, provide these measurements, get them all together, and place them in the TPM. We can then ask the TPM to create encryption keys that are based on these keys. Turning on BitLocker essentially does exactly that. We take a snapshot of what the platform looks like. We use that key to encrypt everything on your volume, including the white space, including the blank space, so that at the sector level, everything remains encrypted. After we've gone through all of those measurements, once we turn on BitLocker, from now on, every single time that we start that machine, every single time we turn it on, we check to make sure that the current measurements of that platform match those original measurements which we use to create that key. Thus, if someone has, say, substituted in a rogue BIOS, or someone has tried to boot onto a CD with certain hacking utilities or different tools, some of those measurements will be different. Some of those things will be changed. The TPM can help detect this, and it won't be able to release the keys to the data into the rest of the operating system. So what exactly are we encrypting? As you can see here, everything in the orange volume, the OS volume, is what remains encrypted. Now, obviously, the most important is the data. This is the intellectual property, the time and effort that people spend to generate their value. Also, we encrypt anything that's temporary files from the operating system, hibernation files. Essentially, anything that is unique or valuable goes on this partition where, while BitLocker is enabled, this remains encrypted. We know that anything that's identifiable or valuable needs to be protected, and we've designed BitLocker with that in mind. You may also notice that there's another piece of this little blue partition, the smaller piece. Now, before I cause any confusion with that, I'll just point out that I know that the MBR, the master boot record, is not actually in a partition. It exists outside the partitions, but I've included it here to show that it remains unencrypted. These pieces in the system volume remain unencrypted for a number of reasons. The first is that the computer needs to have a way to essentially to become smart enough to be able to unlock a volume, to be able to load an OS. Without these additional instructions, that type of processing isn't possible. Second, these pieces can remain open, unencrypted in the plaintext, on the clear on the drive, fairly safely, because even if you were to take them out, analyze them, read them all day, what you're going to know is that, okay, you have a few partitions, and maybe some of them know how to load an operating system. This isn't key data, and this isn't going to make any headlines. Last, if you note with the TPM, those files that remain on the system partition, those things that are helping start up the operating system, helping load the computer to the point where it can manage applications, those pieces are the things that we are measuring with the TPM. When we're taking those hashes, storing those values, if any of these things that are in the clear are replaced or modified with something else, the TPM will be able to detect this and to help to protect access to the rest of the volume. So what types of threats are there? Now, BitLocker has been designed to be able to provide protection that fits each scenario. Whether you are an enterprise, whether you are an individual user, BitLocker has been designed to be able to have something for everyone. Now, obviously, some data is more valuable than other data. But there's 3 different ways in which data can be compromised. The first is, of course, just the most obvious. This is the type of thing that happens all the time, where someone's tired, they come home, they leave their laptop in the coffee shop, or they leave it in a cab, they leave it on an airplane. This thing happens all the time, and it's something that if it's a business laptop, the actual cost of the hardware is the least of your worries. Having to go back and replace all those passwords, or maybe reset some of the network shares, or having to re-image and redeploy another machine. The actual cost of that lost hardware is the least of your worries. Now, a second major way that data is lost according to accident or by carelessness has to do when a large organization is ready to retire several thousand machines. Now, looking at these numbers and the statistics, it is scary how often these things aren't even erased. People don't go into Windows and just delete files. These systems often go out into the wild or into parts shops where data is accessible to whoever happens to find it. Now, obviously, most places have policies for this. You can delete data, you can erase data, but if you don't want to fully demagnetize or completely destroy a drive, BitLocker actually provides the ability for you to purge all the keys on an encrypted volume. By doing that, the data is not coming back, but it's pretty safe to just allow this computer to be redeployed to anyone, format. They can go off and do what they want with it later, but that data remains encrypted with no way to get back to it. Now, of course, if you've ever seen a drive ground into powder, it actually looks and it sounds really cool, but as you probably know, it's very expensive. Now, a second and definitely more troubling way for data to be lost or data to be compromised is that of the intentional threat. This is what happens when you see someone in a nice suit get out of a cab by the airport, they put down their laptop case and they walk over to pay the driver. Someone else standing nearby sort of does the mental calculus and figures out, maybe it's worth snatching that laptop and trying to outrun this guy for whatever's on it, as opposed to seeing the high schooler in the coffee shop where it's pretty much guaranteed that it isn't. With that type of data, these type of people are going to try intentionally to break into that data. They're going to use fairly effective tools to be able to do that. And the last type of threat, the last type of thing that we consider, is that of the targeted threat. Now, a system becomes targeted when it is known to have data of value on it. This could be either the branch office server, which more often than not is sitting under a desk somewhere, just mostly forgotten about. Or maybe this is the laptop with the government seal on it. Maybe this is the CEO's desktop that walks out of his office in the middle of the night. All of these things contain data that can be of tremendous value to unscrupulous people. Also, they can cause a great deal of damage if this information is exposed. BitLocker has been designed to be able to help provide an additional layer of protection in all of these scenarios. So what are some of the ways that BitLocker can be set up? Now, I don't much like this slide, and that even after 20 revisions, it's very difficult to explain, very difficult to understand. I think at least for those of you here today, I'm going to try to explain it in such a way that you will know what I'm talking about. So let me just call your attention to the arrow over there on the right. What this diagram is representing is how easy it is to deploy and then maintain a given BitLocker configuration within a large enterprise. I guess we'll just dive in. We'll start on the left. With TPM plus USB, having an external USB device, a user must protect and carry around an actual USB device for that computer. And every time that computer turns on, every time you want to reboot or resume from hibernation, or when that data could be at risk, they'll need to insert this USB key. Now, this provides the advantage that the key material is actually physically separate from the machine. So, machine gets stolen, key stays here, attacker is very sad. Now, if you are the type of organization that already manages USB keys, that you deploy these for your employees, and you have the type of infrastructure and experience necessary to deal with them when they are inevitably lost or broken or recycled, then by all means, use TPM plus USB. You will be very happy and you will be in great shape. However, if you're new to this, or you're not sure exactly which configuration you want to go with, honestly, I don't recommend the USB options. If you're not prepared for it, it can be more overhead, more difficult to manage than you're prepared for, and you could have been much happier with a different type of configuration. Next, let's move to TPM plus PIN. Now, TPM plus PIN allows that instead of having a USB device to help boot the computer, the user can specify a 4 to 20-digit PIN that will be entered in all of those same situations, when you're booting, when you're resuming from hibernation. This helps provide the advantage that the key material just isn't in the clear. It's going to be protected by a TPM and by this PIN so that every single time it starts up, the computer is going to be stopped before it ever even gets close to reaching an operating system or at operational level, because this PIN won't be provided. Now, of course, this also has additional management infrastructure and additional resources necessary to manage all those pins for all those users. But this provides some great advantages. Now, the last, and what we expect to be by far the most common deployment, the most common way to use BitLocker, is that of TPM only. TPM only provides the clear advantage that it is completely transparent to the user. If it's deployed right, if it's set up right, they don't ever need to even know that it's there. The TPM will sit there quietly protecting your computer. The user doesn't have to do anything. They don't have to remember anything. They don't have to carry anything. And they're able to just rest assured that that computer is being additionally protected by that TPM. Now, when worse comes to worse and that computer finds itself disassembled, laying somewhere on a hacker's workbench, at the very least, that TPM protection provides a very significant layer of protection to help protect that data. So let's take a look at what this might look like for a given ultimate user. I have a laptop here, which is by no means a great deal of performance laptop. This, as you can see here, is an HP Compaq NC6320. I think on the HP website earlier this morning, this machine starts for a little less than $1,100. So it's a comfortable mid-range business laptop. See if we can bring up the screen here. If you've never seen Windows Vista before, as I imagine most of you have after this conversation, but just in case, this is what one of the interface can look like. You'll see Arrow Glass, which is our new way of displaying the start menu, some of the graphical options that enable people to be able to use their computers. I'm just going to show you briefly how a Windows Ultimate user, a home user, might be able to encrypt and turn on BitLocker. Now, if I move into the control panel, this is where most of the security settings are kept. As you can see here, there's just a security tab. And at the bottom here is something called BitLocker Drive Encryption. Now, let's say I want to turn on BitLocker Drive Encryption. So the step there is fairly obvious, fairly straightforward. Click the button. Now, what you see here used to be known as Lua, but now it's actually called User Access Control. As you notice, it's not just a pop-up, but it actually dims the screen to help differentiate and help the user understand that this is a system-level pop-up, identifying that some operation that could potentially be at risk is about to occur. This helps provide additional security for untrusted processes that may be running, to be able to have the user decide, yes, I do in fact want to run this. And as I do intend to encrypt BitLocker, I'll just click continue. And we'll wait for the user interface. There we are. We can see that this computer has been set up with the right partitions. All we need to do, click to turn on BitLocker. Now, as we just went over, there are a number of different configuration options for BitLocker, a number of different ways it can be set up. I think for this one, I'll just set it up with a startup PIN so that every time I reboot this machine or every time I turn it on, I'll have to enter my PIN. Don't use 1, 2, 3, 4 because everyone's going to guess that. I'm just going to throw that out there right now. Don't use that. So I'll just do something simple, a 4-digit PIN, and set my PIN. Now, what happens if I forget that PIN? What happens if that PIN is lost or if someone else needs access to my machine after I leave the company? Being able to create a recovery password allows me to safely manage this hard drive without the risk of losing it completely if I forget the PIN. Setting this recovery password can be backed up in a number of different ways, which we'll go into later. But for now, let's just look at what the user interface looks like. I can save this recovery password, a long key, on a USB drive. I could save it to a folder. I could just take a look at it, write it down somewhere. Or I could print the password. I think for the purposes of this demo, since I happen to have my keys and a USB drive on me, I'm going to back up the password to a USB drive. So I'll simply insert the drive. Close that. And save it to the USB drive. This way, if I forget my PIN and I want to boot the machine, all I do is find that USB drive, plug it into the machine, and that will allow me to get back into the operating system and reset my PIN. As you notice down here, if you can read it, the recovery password has been saved. Now the next step is to actually have to go through and to encrypt this drive. This is the drive that we want to start up, so I'm just going to go ahead and click encrypt. What this is doing is physically seeking to every sector of that volume and encrypting it with the measurements that are on this machine. And this may take a while, but we'll refer back to it back at the end of the presentation and see how it's going. See if we can bring this back up. Great. So, as you've just seen, I've just turned on BitLocker. It's in the process of encrypting, but when we look back on it, when that's done, that machine will be BitLocker enabled. There are a number of different things that might happen that might prompt me to have to go to a recovery scenario where I wouldn't be able to just boot normally. As the most obvious one is, of course, if I lose my USB key, if I had set it up that way, or if I lose my PIN. The second is an unplanned upgrade to core files. What this means is all those different pieces of the boot path that we looked at in the earlier slides, if I didn't use the BitLocker ability to just temporarily disable, make my changes, and re-enable, like someone had flashed my BIOS in the night, or an IT administrator comes by the office and just wants to flash that BIOS, if that had been changed without disabling BitLocker, BitLocker will boot up, notice that something has been changed, and prompt me to recover. Another operation that might cause recovery is what happens if that machine breaks. What happens if I drop my laptop or we're playing a game of office football and a desktop falls off to the table. Hardware inevitably gets damaged or gets hurt, gets destroyed. BitLocker provides the ability to still be able to unlock that hard drive so you won't lose the data if you're losing the rest of the machine. By moving that hard drive to a different machine, you won't have the same TPM measurements. You won't be able to just use your PIN or use the USB, but you will have the ability to use this recovery password to get to the data. This helps provide for mobility and a redundant layer of security for different organizations. Now the fourth, and by far the most disturbing, is that of the deliberate attack. If someone finds this laptop after it's done encrypting, someone walks away with this half an hour from now when we're done, if they were to insert a disk with hacking utilities or insert a CD-ROM drive, do something to the BIOS, whatever they're doing, if they make that modifications, they break something or they change something that will enable them to encourage a security vulnerability, the TPM will be able to notice this and will prompt for recovery. If they don't know that recovery password, they have their work cut out for them. Now, we just looked at some of the ways in the UI for how this recovery password can be stored. But one of the most exciting features about BitLocker and what makes it something that is usable on enterprise scale is what's the recommended method for domain joined machines. By using group policy, you can configure the setup process so that when a BitLocker machine is set up, it automatically stores those keys back in a centrally managed secure location, which is your server, your Active Directory server. Then, if a user in your organization forgets their PIN, they break their USB drive, something on the order of that happens, they can call up the admin, verify who they are, and get that recovery key to be able to type it in and get back into their machine. This makes it easy to manage on a level where you don't have to keep track of 100,000 different USB keys that I use for recovery. You can keep track of one machine in an Active Directory server. Now, all these methods apply to regardless if you're in a domain or if you're not. But for an enterprise or for an ultimate user where you're not likely to have 50 machines, where you're not likely to have an Active Directory setup, there are a number of different ways. What I did was just back up to a USB drive. So now that if I forget my PIN or if I don't know what's in there, I take that USB drive out, plug it in the machine, and I can get back to where I'm going. We can also, by the time we switch to RTMs, we'll have the ability to do a free web-based key storage service through a program called Windows Ultimate Extras. Download the program, put your keys up on the web. You don't have to worry about them. You don't have to keep track of them in your house or where your USB drive is stored in your sock drawer or wherever it may be. When and if and when you have the problem that you need to recover, contact the service, get the recovery key. Everything is managed in the background for you. Now, as I know there are many OEMs in the crowd, one of the things that can add additional value to your customers, that if you can find a way to make this something that is enticing or even profitable, is just the alternative availability to provide a key storage service. If you can reduce the total cost of ownership, if someone wants to buy 100,000 machines from you by storing some of their keys, this is another way to just add value. As you may mention in the GUI, the graphical user interface that we just took a look at, one of the other options was to back up to a file. If I don't have a USB drive lying around, I could back up my recovery password to a disk, back it up to a CD, back it up to a different hard drive, back it up to any number of different things. Anywhere a file can go, that recovery key could go. And later on, I can access that recovery key, put it on the media I need it to, and be able to access the drive. The last is, of course, printing or just recording to physical media. But this is a nice way of saying write it down on a napkin. Of course, this isn't something that we recommend because it's perishable media, but you have the ability to just put it on the screen, write it down somewhere, send it in a letter, mail it to grandma's house so it's not with your computer, and so it's not nearby, and it's not in jeopardy if someone is able to take that machine. Now, we've heard about some of the great innovations and the number of things that BitLocker has provided and that Vista has provided, and we've seen a lot of great development in hardware over many years. But up here is a list of some of the things that we've seen some of the least traction on, some of the least abilities, and some of the most outstanding vulnerabilities that all of us together can collaborate with. They're in no order of importance. They're just up there for your reference. The first is that of BIOS modification. Now, a hacked BIOS can be detected, but a BIOS hacked in the proper ways does have the ability to potentially reset some of the measurements and introduce additional vulnerabilities into the platform. The first mitigation for this is something called a secure CRTM, or core root of trust measurement update. This is actually a logo requirement, so it's important to pay attention to this one. If you have a BIOS on a machine, what the secure requirement means is that your CRTM or your BIOS must be immutable. Immutable can either mean that it is ROM, it's read-only memory, it will not ever be changed, or that it has the ability to be securely updated, which means it will only accept a digitally signed update. So any pending updates are checked first for their validity, then applied. This means that if I were to create a hacked BIOS in my shop, write something up, the code that's currently on there, the current BIOS, will reject that pending update because it doesn't have the correct digital signature. And the second mitigation for something like this is something that the user or the enterprise can provide, of that of providing an additional layer of protection through using the PIN or the USB configurations for BitLocker. If you need something else to be able to produce that key and to get it into memory, just being able to do what you want with the machine isn't enough to be able to obtain that. If you can add this additional protection, this can only help mitigate this type of attack. The next type of threat is that of physical memory. Now, obviously, once everything is authenticated, even during the normal course of business, at some point, the keys have to be in the memory so that they can be used, so that we can read through the sectors, unlock things, and do this in a way that is performant. Now, the first mitigation is, again, something that the BIOS can do. This is also a logo requirement. It's something called memory overwrite on reset. This means that if I have memory that can battery back DIMMs, for example, or something that can store information for a little while, whenever that machine is powered up, the BIOS will actually walk through all of the memory and clear it. This prevents an attack where someone could quickly boot into another OS or another application and just dump the contents of memory and try to analyze what's there. The second mitigation is the same as up there at the first, is that you can also provide this additional layer of protection through using the PIN or the USB. The TPM-only mode is great, and that's supported for most of our customers. This is something that we definitely recommend. But if you're worried about this type of threat, try to provide this additional type of protection. The third type of something is something called a dictionary attack. Many of you may be familiar with this. This is essentially where someone just keeps guessing different combinations until they get that PIN. If you're a TPM manufacturer, I'm sure you're already familiar with this, but if you are evaluating a TPM manufacturer, or if you are interested in knowing what this is about, ask them, what is your dictionary protection logic? This is something that is a logo requirement. This is something you absolutely must have to be able to protect a PIN. Otherwise, I'll guess through that and be able to compromise a PIN very quickly. With the right hacks, a number of pins can be tested very quickly because this isn't something someone would have to type in. If you can devise a computer program to do this, with no dictionary attack protection, a 4-digit PIN can be hacked very, very quickly. If you have any questions about that, or what we recommend, or our guidance, or about dictionary attack protection, please do contact us. There's lots of information at the end of the presentation, and we can give recommendations. The last threat, and the one that will always be prevalent but can be mitigated, is that of the end user. Ultimately, any security technology depends on the people using it safely. If your users aren't informed that they should not keep their USB key in the laptop case with the laptop, or if they write down their PIN on a sticky note and leave it on the monitor, those types of things are just like leaving the keys in the car. This doesn't provide the additional protection that BitLocker's intended. So that type of user education and mandating a corporate security policy where people understand the threats and understand that this circumvents some of those protections is an important way to enhance security with BitLocker. Now, this is the part that is definitely becoming of most interest to OEMs. This is the part that if you take away nothing else from this presentation, these are what you want to remember. As you know, the Vista Logo program is designed to help provide the best hardware from the best manufacturers with Vista. There are 4 different logo requirements specifically targeted to BitLocker. Machines that want to use BitLocker need to be compliant with all of these requirements. This is where you will know exactly what you need to do. If you're not sure if you want to be compliant or how to be compliant with BitLocker, take a look at this. The first is, if you have a TPM on that platform, the TPM must be a TPM version 1.2. TPM version 1.2 has a number of advantages over the TPM 1.1 in that, first of all, that it must be memory mapped I/O. Old port I/O systems from the TPM 1.1 contained a number of different implementations in different ways that helped greatly expand the attack surface and make it very difficult for a driver to be able to universally communicate with all of them. By having a TPM 1.2, memory mapped I/O, and locality 0, we can help siphon and funnel down that communication to the TPM to provide greater security. If you have any questions about this, again, ask your TPM supplier, ask us. We can help point you in the right direction. The specifications listed up here are all part of something called the Trusted Computing Group, the TCG. There's materials like that at the end of the presentation. I think they have representatives here at this conference as well. But this is an international organization of many large companies all collaborating to help make platforms better. Some of these specifications are publicly available. And if you're building a TPM, you're interested in a TPM, this is where you'd go to find out the actual nuts and bolts of how they are put together. The second logo requirement is that of the BIOS. Now there's a TCG contains a subgroup called the PC client. Their BIOS specifications can be found at these links, but they provide the ability for a BIOS to be Vista and BitLocker compliant. Three of the things that are important to note if you're designing a BIOS, and especially important for BitLocker, are listed below. The first is something called a physical presence interface. What this means is that there's an interface that allows someone to be physically present at the machine to change states within the TPM hardware. I mean, to enable it, to take ownership, to do other operations that have a security bearing. Taking care of this physical presence interface allows the operating system to obtain this information from someone, from the user, and to be able to effectively use it to toggle that state. There's something also called the memory overwrite specification. This was covered in the last threats, but again we listed here in that this is something that needs to be implemented for every BIOS on Vista and on BitLocker because of the threat that a key material left in memory might provide. And the last is the immutable CRTM or the secure update. By having the ability to make sure that that CRTM, those first steps of code when the computer first turns on, if those can be trusted, we have a much greater assurance that everything built upon that foundation can be trusted as well. The last two requirements, the first of which is the hard drives, has to do with this. BitLocker requires at least 2 partitions. If you remember the diagram with the orange block and the blue slice, BitLocker requires a small piece to remain open, unlocked, and in the clear so that the rest can be effectively protected. By having an active NTFS system partition of a minimum of at least 1.5 gigabytes, we can provide the security and flexibility necessary to use BitLocker. The OS and the other partitions on the drive can all be of any size, but this is very important for BitLocker-enabled systems. The last requirement, and the last one to be aware of, is that of USB. There are 2 different requirements here listed, as you see the numbers. One of them isn't BitLocker specific, but I've included it here because if you're working on USB technology, this is something that's going to be just important to recognize to make sure you're fully Vista compliant. That you must be able to have the ability to boot from USB. You must have the ability to read the keys that might be on a drive, a USB drive, to unlock BitLocker in the pre-OS environment. This means that the BIOS needs to be able to understand USB interfaces, to be able to read and write and boot from the USB, even at those early stages. It can be formatted with any of the Windows file systems. As long as it has that data, we'll be able to read it and use it to help BitLocker unlock the drive. There's an email address that you may have seen that's repeated throughout the presentation called BDE, BitLocker Drive Encryption Info. This is a general alias that copies many members of our team and can be used for any questions related to logo requirements, related to BitLocker, related to TPM technology. If anything that you have is not clear after this presentation, please send us an email there. We'll be happy to help provide additional information, documents, whatever might be useful to you. So while I'm up here and I had the opportunity to address some of the enterprise concerns, I just wanted to point out some of the things that OEMs and system builders can really take advantage of and start planning for right now. The first is that of remote deployment considerations. If someone is looking to purchase 100,000 machines from you, think through the process. How can we make it easier? How can we make it as straightforward and as low cost as possible to be able to do this? If you can provide a solution to enable remote initialization of TPMs securely and safely, and provide that secure BIOS update mechanism, this dramatically reduces the overhead and the deployment cost for an enterprise and makes that platform much more desirable. The second of which has to do if you use WinPE or pre-environment as a recovery environment, make sure that you include components like Windows scripting host. These components enable the command line tools to be able to have access to BitLocker, to be able to recover a drive without having to boot into the OS. And last is to ship your systems with an endorsement key. For those of you that don't know what it is, that's okay. But for those of you that are TPM manufacturers, OEMs developing platforms with TPMs, make sure that the TPM, wherever it happens, before it gets to the user, ships with an endorsement key. Generating it in the field is not only time-consuming, but it's a number of security risks associated with that platform. If it doesn't come from a trusted source, if that unique identifier of that TPM, that unique key, to encrypt those keys or to encrypt the drive is not provided before it ever reaches the user, that platform is fundamentally less safe. So let's take a look at just the last things to remember. For BitLocker, those are the 4 logo requirements. TPM 1.2, just consider how it's going to be deployed, how it's going to be enabled, how it's going to be enabled and activated and used on an enterprise environment. For your BIOS, make sure that your systems ship with those different components. Make sure those key pieces of the BIOS are developed to help close the holes in the security that the OS doesn't have the ability to provide. With the hard disk, make sure that the platforms for BitLocker ship with at least those 2 partitions as identified previously. And for USB, make sure that you can read it, you can write it, you can boot from it in the pre-OS environment before all the drivers for everything are loaded, before an OS comes up. We need the ability to obtain materials from these keys. Enterprise customer needs, I think we've covered that. Helping them deliver solutions, helping provide an easy out-of-the-box experience is a great way to help add value to your platforms. And last, and something I should stress, is that test your platforms. Test them 2 weeks before Vista RTM and you need to run and scramble to try to get a logo. We will happily partner with you and help you to develop those systems, to see how they're working, to encourage or to lend support and direction on how this should be done. You can send us platforms, reference platforms as they're being developed, and also you can test by yourself with those with the CDs. You might notice Beta 2. If you have an MSDN subscription, you have access to WDK, Windows Developer Kit tools. You have the ability to test these things and to make sure that everything is in line and that the Vista deployment experience for you and for your customers will be as comfortable as possible. The last is just that of additional resources. We can look at this. This is downloadable. You can use it at any time. But it's important to note that everything necessary about BitLocker, about the TCG, about how this should be built, it's all readily available. There's a session after this one that will go into much more detail about the server end of things and about Active Directory and about some of the important other aspects that I'm not able to address in the client version of BitLocker. Also, if you have any questions about BitLocker, any ideas for us, anything that you want to be able to tell us, that email address, BDE, BitLocker Drive Encryption Info at Microsoft.com, is available to us, it goes directly to the team, and we provide responses very quickly.